All right, so question number 9 says the circle below has center O and the points A, B, C, and D are on the circumference. A straight line passing through A and B. A straight line passes through A and B. All right. Um, Angle CBD is 49 degrees. We can see that. Angle OAB is equal to 37 degrees. I is asking us to write down the mathematical names of the straight line BC and OA. Well, BC is a chord and OA, a line drawn from the center of the circle to the circumference, is a radius. Next, determine the value of each of the following angles, show detailed working where necessary, and give a reason to support your answer. So X, we need to see how we're going to get X. All right, where's X? Oh, X is there. Guys, if you look carefully, you'll notice that this is an isosceles triangle. OAB is an isosceles triangle. If you look carefully, you'll notice that. All right, so if that's an isosceles triangle, AX, where O is the apex, and down here would be the base, and the two base angles of an isosceles triangle are equal. So that's 37 degrees. So therefore now I can say X is equal to 180 minus 37 plus 37. This is 180 minus, what is this, 74. So X is 106 degrees. And the reason for that is that these are the interior angles of an isosceles triangle. All right, so we have X. Next, we're gonna have to determine what Y is. And I'm also thinking that we're gonna need to determine what Z is as well. Going back up. So Y. All right, to determine Y, I'm gonna use the fact that this angle is 90 degrees. That angle is 90 degrees. It's called an angle in a semicircle. It's called an angle in a semicircle. So the line BD is a radius. It's a straight line that passes through the center of the circle that connects the circumference at 2 points. Now, if you start from one end of your diameter up to the circumference and then down to the other end of the diameter, the angle that is formed at the circumference, that is the angle at C, which is called what? It is called the angle in a semicircle. So I'm going to use the fact that that is 90 and the fact that the angle in a triangle add up to 180 degrees to find Y. So for Y, I'm going to tell the examiner that angle BCD is equal to 90 degrees. The reason BCD is an angle in a semicircle. So the angle at Y would therefore be equal to 180 minus 90 plus 40 something plus 49. plus 49. So this is 180 minus 139. This is 41 degrees. And my second reason is interior angles of a triangle. All right. I'm guessing they probably want, no, well, they don't want Z. There's no Z, it's just Y you have to find. So now we're at B, the B part of the question. Now, the B part of the question is on bearing. All right. So let's get this proper. This says the diagram below, not drawn to scale, shows the route of a ship cruising from Palm City, P, to Quayton, Q, and then to Rivertown, R. The bearing of Q from P is 133 degrees, that is shown. The angle PQR is 56 degrees, that is also shown. We're to calculate W. Now, to calculate W, I'm going to use the fact that two north-south lines are parallel. And once you have parallel lines cut by a transversal, you can have alternate angles. And if you look carefully, you can see that these two angles here are alternate angles. The angle here and the angle here are alternate angles. Alternate angles are sometimes called Z angles. And this is because two north-south lines are parallel. So I can say W plus 56 is equal to 133 degrees. These are alternate angles. All right. If I want, I can write my reason down here. Alternate angles. Well, I don't think it matters in this question. It's not like the question before. Let's write my reason beside it. So W is equal to 133 minus 56 133 minus 56. W is equal to 77 degrees. So W here is 77 degrees. What next now do we need to calculate? We need to calculate the bearing of P from Q. So we need to show the angle that represents the bearing of P from Q. All right, the angle that represents the bearing of P from Q. Let's change the color ink to blue. All right, I'm taking the bearing from Q. So I need my north, south, east, west line at Q. Now, bearing is measured clockwise from north. So I start from north and I come around. Start from north and I come around. So that angle there in blue represents the bearing of what? P from Q. All right. Between north and south is 180 degrees. W is 77 degrees. And inside the triangle there, we have 56 degrees. So the bearing of of P from Q is equal to 180 plus 77 plus 56 plus 56. So that becomes 313 degrees. 313 degrees. Next, we need to calculate the distance RP. We need to calculate the distance RP. This distance here, I'm going to call it X. Now, looking at triangle PQR, I can easily see that it's a non-right angle triangle. I know the length of two sides. The two sides are 210 and 290 kilometers. And the size of the angle between them is 56 degrees. So if I have a non-right angle triangle, the length of two sides and the angle between them, and I wish to find the length of the third side, that is a condition for applying the cosine rule. Now, the cosine rule is a square is equal to b square plus c square minus 2bc cosine a. That's the cosine rule. A is the side opposite the inclusive angle, which is the 56 degrees, and the side opposite to the 56 degrees is x. B and C are the other two sides. I think it's 210 plus 290 minus 2 times 210 times 290 times the cosine of the angle between them, which is 56 degrees. All right. Now, I often just tell students to put this in a calculator and press equal. All right, I made a slight error. This should be square. Put this in a calculator and press equal. So it's 210 square plus 290 square minus 2 times 210 times 290, the cosine of the angle between them, which is 56 degrees, close bracket and press equal. This is 60,090. At least I think that's what, 0.3. Now the opposite of square is square root. So x, which is RP, is the square root of 60,000 and 90.3. The square root is RP is equal to 245 kilometers. RP is 245 kilometers. Let's see, is there any, and that's the last part of the question. All right, that is the last part of question number 9.